Hey folks, welcome back to another video. Today we're looking at question 1354, construct target area with multiple sums. The way we'll be approaching this problem is by looking at the max number that's given in the entire array that's provided to us and subtracting the sum of the elements. Let's look at an example here. So the first example that we're looking at is 935. So what's the maximum element that we have here? We have 9, and then we need to get the sum of the rest of the elements, which are 3 and 5. So we need to subtract the sum of the rest of the elements from the max, which gives us 1, 3, and 5. And you need to keep doing that till you have all 1s. So let's go through this example that we saw. So you have 935, you have 5 and 3, that is the sum of the rest of the elements. You subtract that from 9 and you get 135. In the second iteration, you have 135. And what's the maximum element here that we have? We have 5. The sum of the rest of the elements is 3 plus 1 equals 4. You subtract that from 5 and you get 131. And you look at this area again. The max that we have here is 3. The sum of the other elements are 2. So 3 minus 2 equals 1, and you get this particular array and return true. So that's the method that we'll be using for the solution, but there's something else that we need to understand before we start coding it up. Let's look at this example. We have 10 and 3. We subtract 3 from 10 because it is the biggest element. We get 7 and 3. 7 is bigger than 3. We subtract 3 from 7 to get 4 and 3, and then we repeat those steps till we get 1 and 1. However, we could have skipped all of these steps just by doing a modulus. So the max element that we see, we mod that by the sum of the rest of the elements. So in this case, it would be 3. So 10 modulus 3 will give us 1. And then you have 1 and 3. And that is reducing all of the steps that you see right here. So we'll be using these two concepts to code up the solution. So let's jump right in. Let's initialize a variable called max that will store the max element, and then we'll have max index also equals to 0, and then let's get sum. We'll initialize sum as long because you want to make sure that there's no buffer overflow. Awesome. So next up we have all of the elements. We add them up. Right. So sum plus equals target of I. Next up we need to also keep a track of the sum. So if target of I is greater than max, you assign the new value of max as target of I. And then you need to assign max index to I. Awesome. So once we have the sum, what do we need to do? We need to subtract the max element from it. So what does it look like in our example, right? So we have 395. We've identified the max as 3, and you have the sum now to be 8. So now you can check for base cases. You can check, hey, if the sum is equal to 1, or if the max is equal to 1, you can just return true. We know that we've hit our base cases, and you can return true. And then there are a couple of other cases that you need to check. If sum is equal to 0, as in the sum of elements in the array cannot be 0 because they all have to be 1. If it is 0, or if the max is less than the sum, so the sum is greater than the max that you see, which shouldn't be possible from the examples that we saw right here, or if the max modulus sum equals 0 right here. So for example, if this was 9 and 3, we know that we can never come with an array that is like 1 and 1. So if any of these base cases hit, you know we can not achieve the goal and you would return false. if nothing has been returned here and here, you know there have to be more computation. So for example, you're done with step 1, you still need to continue doing that. So to make it easier, the max that we have, we multiply by the sum. And what do we need to do next? We need to reassign the max value. So let's do that. We kept track of the index using a max index right here. You need to reassign that as max, and then you need to call this method again, is possible, with the new updated value in the array. Awesome. So let's compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is n squared, since we are going through every single element within the array itself, and you're calling it recursively. And then the space complexity of the entire solution is of 1 if you're not considering the recursive stack, since we're not using any additional data structures to store any data. Awesome. So that's the solution. If you have any questions, please let me know in the comments below. Don't forget to subscribe. I would really appreciate that. And I'll see you all in the next video. Peace.